The last lesson of this unit is on a concept or an idea of something called an inverse function. So we're going to start with a little introduction problem to have an idea of what inverse functions are, and then we'll get into the definitions and more details about this. So if we look at these two graphs below, f of x in red and g of x in blue, from Unit 1, we should be able to answer these questions using function notation. What is f of 2? Oh, it's not very good. F of 2, and you can look at the graph right now and say it to yourself before I say it out loud. F of 2 is, so when the input on f is 2, the output is 0. So there's a point here at 2, 0. So f of 2 is equal to 0. The next question says, for which values of x is g of x equal to 2? So that's g of what? Oh, let me use blue here. So g of what is equal to 2? So we want to see when the output on g is 2. So if you look over at the blue graph, you should see that there's a point at 0, 2 on the blue graph, 0, 2. So that means that g of 0 is equal to 2. All right, next we have what is g of negative 3? G of negative 3. So look at the blue graph. When the input is negative 3, it looks like there's a point here at negative 3, positive 1. So we have negative 3, positive 1. And then on the red graph, we can see that f of what is equal to negative 3. And maybe you're noticing a pattern at this point. F of what is equal to negative 3. And we can see that there's a point at 1, negative 3 on the red graph. 1, negative 3. That's not very pretty. There we go. So f of 1 is equal to negative 3. So what patterns do you notice? Well, I hope that you notice that the x and y values are switched from the blue graph to the red graph. And so when f of 2 is 0, g of 0 is 2. We're kind of switching the inputs and the outputs here. And what we call f and g is we call those two inverse functions. When every single point on f can be reversed to get a point on g, that means that, or vice versa, from g to f, that means those two functions are inverses. So let's go ahead and write down the definition of an inverse function. We have that here. The inverse function, so if we're given a function f of x, we denote the inverse of f of x. We give it a special name if it has an inverse, and that's f inverse of x. Notice it's a little negative 1 exponent, so you write it, I'll write it also, f inverse of x. And what that means is that it's the function whose x and y values are the opposite or have been interchanged with the original function f of x. And that's, again, the special notation that we use for the inverse function. Please understand that this notation does not mean, you may remember from previous years, negative exponents, like if you have x to the negative 1 power, you can rewrite that as 1 over x. That's a negative exponent. That is true. But that's not what this notation means. This does not mean 1 over f of x. It's a special function notation. It doesn't mean the reciprocal. It means an inverse. So that's very specific just for function notation, that this does not mean a power of negative 1. If you have a plain variable raised to a negative 1 power, that does mean the reciprocal, but not with this function notation. So do not mix that up as this unit goes on or as your future math career goes on.